हेलो, गुड आफ्टरनून टू ऑल ऑफ यू। लास्ट लेक्चर में हम लोगों ने डिस्कस किया था पॉइजन्स रेशियो और हुक्स लॉ और कैलकुलेशंस किए थे आपके डिफरेंट डिफरेंट बार्स में, स्टेप्ड बार्स में। आज हम लोग डिस्कस करेंगे जनरलाइज्ड हुक्स लॉ एंड रिलेशनशिप बिटवीन इलास्टिक कांस्टेंट्स। ओके, ओके। In last lecture we have discussed about Poisson's ratio. एक बार आज फिर डिस्कस कर लेते हैं व्हाट इज Poisson's ratio. Poisson's ratio, it is the ratio between it is the ratio between lateral strain and lateral strain to longitudinal strain. Longitudinal strain. Longitudinal strain or linear strain. What is longitudinal strain and what is lateral strain? Let us consider a shaft of length L and diameter D. Okay, which is subjected to a tensile load F. Due to this tensile load, here the length of the shaft will be increased. Okay, and let increase the length increase in the length of the shaft is delta L. Okay, and due to this tensile load, the diameter of the shaft will decrease. Okay, let the decrement in the diameter will be delta D. In that case, here change in dimension along the line of action of the force. Here strain along the line of action of the line of action of force or parallel to the force, parallel to force will be, तो लाइन ऑफ एक्शन के पैरेलल जो डायमेंशन है वो है लेंथ, और चेंज इन लेंथ है डेल्टा एल, इनिशियल लेंथ है एल, then in that case strain along the line of action of the force will be delta L upon L, change in length upon initial length. Here, due to this tensile force, the length of the bar will be increased, so the strain will be positive. Okay. Now, strain perpendicular to the line of action of force, line of action of the force will be equal to the, here the dimension which is perpendicular to the line of action of the force is diameter, and the change in diameter of the shaft is delta d, and the initial diameter of the shaft is d. So the change in dimension upon initial dimension is the strain. Here, due to this tensile force, the perpendicular dimension which is diameter will be decreased, So the strain perpendicular to this line of action of the force will be minus. According to the definition of the, according to the Poisson's ratio, here this strain will be known as longitudinal strain, longitudinal strain or linear strain. And this strain is known as lateral strain. Okay, the strain along the line of action of the force or parallel to the line of action of the force is known as longitudinal or linear strain, and the strain perpendicular to the line of action of the force is known as lateral strain. Here Poisson's ratio is equal to the minus lateral strain upon longitudinal strain. Longitudinal strain. Okay, so here this is equal to the minus delta d upon d delta L upon L. Minus minus will be plus. Okay, Poisson's ratio is denoted by the mu, okay, or 1 by m. This is equal to the, this value minus lateral strain upon longitudinal strain. Okay, Poisson's ratio is dimensionless. Okay, ओके। इसके बाद हम लोगों ने डिस्कस किया था थर्मल स्ट्रेसेस एंड थर्मल स्ट्रेन। थर्मल stresses and strain. Okay. Consider a shaft of length L. Consider a shaft of length L. Okay, which is fixed at both the ends AB. Let modulus of elasticity of this shaft is equal to the E. Okay, let modulus of elasticity of this shaft is equal to the E, and initial temperature of the shaft is T1. Initial temperature of the shaft is equal to the T1, and final final temperature of the shaft or this rod is equal to the T2. Okay, and coefficient of linear expansion of this bar is alpha. Okay, linear coefficient of linear expansion of this bar is alpha. Linear expansion, coefficient of linear expansion means change in length per degree centigrade. Okay, so if the temperature of the bar is rise, if the temperature of this bar is rise, then in that case the extension in the bar due to rise in temperature okay is equal to the coefficient of linear expansion multiplied by final temperature minus in the bracket final temperature minus initial temperature into initial length. ओके, पर डिग्री सेंटीग्रेड के लिए कितनी लेंथ में चेंज हो रहा है, अगर इसके मान लीजिए 1 डिग्री सेंटीग्रेड पर 0.1 mm लेंथ में चेंज हो रहा है, इंक्रीज हो रही है। तो थर्मल कॉफिशिएंट हमारे पास 0.1 पर डिग्री सेंटीग्रेड है। तो अगर 10 डिग्री टेम्परेचर इंक्रीज कर दिया जाए तो टोटल जो चेंज होगा वो 0.1 इंटू 10 होगा। ओके, सो द टोटल एक्सटेंशन विल बी दिस इज द change in the length, okay, delta L. So thermal strain E is equal to the change in length upon initial length, and here delta L is equal to alpha, let's say delta T into L upon L. So the thermal strain will be equal to the alpha into delta T. Okay, and the thermal stress will be stress induced due to this strain in the bar will be stress is equal to the modulus of elasticity into strain. So alpha will be sigma is equal to the alpha into delta T into capital E. ओके, एक सिंपल क्वेश्चन इस पे हम लोग सॉल्व कर लेते हैं। एक सिंपल क्वेश्चन, ओके, क्वेश्चन इज a steel rod of length L and uniform cross sectional area A secured between two walls। एक स्टील रॉड है जिसकी लेंथ गिवन है L, सिक्योर्ड बिटवीन टू वॉल्स मीन्स इसे दोनों एंड से फिक्स किया हुआ है। लेंथ, here length is given 1.5 meters, okay, and modulus of elasticity is 200 gigapascal. Coefficient of thermal extension is 11.7 into 10 to the power minus 6 per degree centigrade, and change in temperature is 80 degree centigrade. Calculate the stress for a temperature increase of delta T। यहाँ पर हमें थर्मल स्ट्रेस फाइंड आउट करना है कि कितना होगा। तो सबसे पहले जो डेटा गिवन है उसे हम डिनोट कर लेते हैं। गिवन modulus of elasticity E is equal to the 200 gigapascal. Okay, here 1 pascal is equal to, we know that 1 pascal is equal to the 1 Newton per meter square, or 1 megapascal is equal to the 1 Newton per mm square। अगर मैं इसे यूज करूं यहाँ पर तो because here length of the bar is in meters, so I changed this unit in meters। Okay, so here E is equal to the 200 into 10 to the power 9 Newton per meter square, because 1 giga is equal to the 10 to the power 9। Okay, and here alpha is equal to the 11.7 into 10 to the power minus 6 per degree centigrade, and change in temperature is given 80 degree centigrade. Okay, now from the equations above equation we know that thermal stress alpha is equal to, sorry, sigma is equal to the alpha into delta T into E. Okay, here alpha is 11.7 into 10 to the power minus 6 into delta T is 80 into E is equal to the 200 into 10 to the power 9. Okay, so here the total thermal stress induced in the rod will be 11.7 into 80 into 200, 187.2 into 10 to the power 6 Newton per meter square. So this will be the stress in the bar, which is 187.2 into 10 to the power 6 Newton per meter square. If we have to calculate the strain, total elongation in the bar, which is equal to 0, the total strain in the bar E is equal to, thermal strain will be equal to the alpha into delta T. Okay, we can calculate this. Okay, now come to the next topic, generalized Hooke's law. Okay, generalized Hooke's law. What is generalized Hooke's law? Now consider a body having or subjected to normal stresses sigma x, comma sigma y and sigma z in x, y and z direction on x, y and z planes respectively. If modulus of elasticity modulus of elasticity is equal to the E, and Poisson's ratio is equal to the mu. Okay, consider a body in a three-dimensional space subjected to three normal stresses, sigma x, sigma y, and sigma z, in x, y, and z direction. Sigma x, sigma y, and sigma z on x, y, and z plane. देखिए, here the plane which is perpendicular to the x axis is known as x plane. This is x plane. Okay, remember this point. The plane which is perpendicular to the axis, the plane is known as x plane, which is perpendicular to the x plane. The plane which is perpendicular to the y axis is known as y plane, and similarly the plane which is perpendicular to the z axis is known as z plane. So here there is three normal stresses, sigma, sigma y, sigma z, which are acting at the x, y, z on and z plane in x, y, and z directions. Okay. Now here strain in x, y, and z direction due to stress sigma x. Okay. Now first, strain along the x-axis Exx will be equal to the, we know that stress is equal to the modulus of elasticity into strain. If stress is perpendicular to the any surface, in that case the strain along the or parallel to the direction of the stress is equal to the stress upon modulus of elasticity. Okay, here strain parallel to the direction of the stress. Okay, remember this point. Okay, this strain also known as longitudinal strain or linear strain. Okay, so here the stress is sigma x. So the strain will be sigma x upon E. Here first suffix stress is denotes here first suffix is denotes the stress and second suffix is denoted the direction. Okay, so here strain due to the x sigma x stress in x direction, okay, will be equal to sigma x upon E. This strain is longitudinal strain. Strain because this strain is parallel to the stress, parallel to the direction of stress. Now second, strain in y direction, strain in or say strain along y axis due to the stress sigma x. Okay, strain due to the stress sigma x in y direction will be equal to the, okay, now the direction of the stress in is in x axis. Okay, here the direction of this stress sigma x is in x axis and the y axis is perpendicular to the x axis. Now here we have to determine the strain perpendicular to the direction of the stress. So the strain perpendicular to the direction of the stress will be the lateral strain. Okay, will be the lateral strain, and according so the strain due to the stress sigma x in the direction of y axis will be the lateral strain. Similarly, the strain in z direction due to the stress sigma x will also be a lateral strain. So here we using the Poisson's ratio mu is equal to the minus lateral strain upon linear strain or longitudinal strain. Here lateral strain is EXY and longitudinal strain or linear strain is EXX. So EXY will be equal to the minus mu into EXX. The lateral strain is equal to the minus Poisson's ratio into longitudinal strain or lateral strain. So minus mu into EXX, and EXX is equal to the sigma x upon E. So EXY is equal to minus mu sigma x upon E. Okay, this will be the lateral strain. Okay, now similarly the strain along z axis due to the stress sigma x will be Exz is equal to the minus mu Exx. Okay, Exx is longitudinal strain. So the lateral strain will be equal to the minus mu sigma x upon E. This is lateral strain. strain in z direction due to the stress sigma x. Okay. Now strain in x, y and z directions due to the stress sigma y. Okay. First, strain in y direction will be Eyy will be equal to the stress upon modulus of elasticity, because the stress sigma y is acting along the y-axis. Okay, so the strain along the y-axis due to the sigma y will be the longitudinal strain, because the change in the dimension or strain is calculated in parallel to the stress direction of stress, and the strain along the x-axis due to the stress sigma y will be the lateral strain, and similarly the strain along the z-axis due to the sigma y stress sigma y will also be equal to the lateral strain. So here Eyy is equal to the sigma y by E, which is longitudinal strain. Okay. Now strain in along y-axis and strain along x-axis and z-axis will be the lateral strain. So the last lateral strain will be Eyx, strain due to the stress sigma y in x direction will be equal to the Poisson's ratio multiplied by the longitudinal strain, which is sigma y by E. This is lateral strain. Okay. Now strain along the z-axis Eyz is equal to the minus mu sigma z by minus mu sigma y by E. Sigma y by E is longitudinal strain. So it will be the lateral strain, because the strain, the change in dimension is perpendicular to the stress. Now the last, finally, strain in x, y and z direction due to stress sigma z. फर्स्ट, z एक्सिस की डायरेक्शन में आपका ये नॉर्मल स्ट्रेस सिग्मा z लग रहा है, तो जो स्ट्रेन है z डायरेक्शन में वो लॉन्गिट्यूडनल स्ट्रेन होगी। तो सबसे पहले हम स्ट्रेन फाइंड आउट करेंगे z एक्सिस की डायरेक्शन में। स्ट्रेन इन z डायरेक्शन और along the z axis। EZZ, stress due to the strain due to the stress sigma z along the z axis, ये हमारा लॉन्गिट्यूडनल स्ट्रेन होगा क्योंकि स्ट्रेस की डायरेक्शन के पैरेलल निकाल रहे हैं। अब y और x एक्सिस के अलॉन्ग जो स्ट्रेन होगी वो होगी लेटरल स्ट्रेन। स्ट्रेन along x axis will be strain due to the z stress sigma z in direction of x will be minus mu into longitudinal strain। ये हो गया lateral strain। Similarly in y direction, strain along y axis due to this stress sigma z will be EZY minus mu sigma z by E, lateral strain। Okay, now the total strain along x axis sigma x will be equal to the sigma xx plus sigma yx प्लस सिग्मा zx। मैंने आपको पहले क्या बताया था, जैसे लिखा हुआ है सिग्मा yx, इसका क्या मीनिंग है? फर्स्ट सफिक्स बता रहा है स्ट्रेस, ओ एक सेकेंड, स्ट्रेन Ex is equal to Exx, Eyx और Ezx। So here Eyx is y is for stress and x suffix x is axis. So Eyx is strain due to the stress sigma y इन x डायरेक्शन। तो टोटल जो x डायरेक्शन में स्ट्रेन है वो x डायरेक्शन में सिग्मा x की वजह से जो स्ट्रेन सिग्मा x की वजह से जो स्ट्रेन है x डायरेक्शन में वो, प्लस सिग्मा y स्ट्रेस की वजह से x डायरेक्शन में जो स्ट्रेन है उसे, और जो सिग्मा z की वजह से जो आपके x एक्सिस के डायरेक्शन में जो स्ट्रेन है हम उन्हें ऐड कर देंगे। तो यहाँ पर Ex इज इक्वल टू हो जाएगा sigma x by E because Exx is longitudinal strain plus minus mu upon E into sigma y plus minus mu upon E sigma z। So the total strain along the x-axis will be equal to the सिग्मा एक्स अपॉन ई माइनस म्यू बाई ई कॉमन कर लेते हैं हम, विद इन ब्रैकेट सिग्मा वाई प्लस सिग्मा जेड. ओके, दिस विल बी द टोटल स्ट्रेन इन एक्स डायरेक्शन. देखिए, जो पहला मैंने आपको हुक्स लॉ पढ़ाया था, वो हुक्स लॉ सिर्फ एक सिंगल डायरेक्शन में लगने वाले स्ट्रेस की वजह से हम एक यूनि डायरेक्शन में जो टोटल स्ट्रेन है उसे हम बता सकते थे. बट अगर कोई ऐसी बॉडी है जो जिसमें 3 डायरेक्शन में आपके या 2 डायरेक्शन में आपके स्ट्रेसेस हैं, तो उस कंडीशन में जो टोटल स्ट्रेन होगी किसी भी एक डायरेक्शन में, एक्स या वाई या जेड डायरेक्शन में, वो तीनों स्ट्रेसेस के इफेक्ट्स की वजह से जो टोटल स्ट्रेन होगा उसके बराबर होगा. ओके, सिमिलरली total strain in y direction, it will be equal to Ey is equal to the Eyy plus Exy plus Ezi. Okay, here Eyy is longitudinal strain, which is sigma y by E, and other two are lateral strain, which is equal to the minus mu sigma x upon E plus minus mu sigma z upon E. Okay, so here Ey will be equal to the sigma y by E minus mu by E sigma x plus sigma z. This will be the total strain in y direction. Now total strain in z direction. Ez will be equal to the Ezz plus Exz plus Exy. Sorry, not Exy, Exz. Eyz. Strain due to the stress y in z direction. Okay. So here Ez will be equal to the similarly sigma z upon E minus mu upon E sigma x plus sigma y. Okay, if the shear strain in x direction is tau x and modulus of rigidity is g, then in that case shear strain in x direction will be is equal to the shear stress tau x upon modulus of rigidity, and the shear stress in y direction is tau y. In that case, shear strain sigma y will be is equal to the tau y upon modulus of rigidity, and similarly, if the shear stress in along z axis is tau z, then in that case shear strain along the z axis is tau z upon g. These 6 equations, Ex is equal to sigma x upon E minus mu by E sigma y plus sigma z, Ey is equal to the sigma y by E minus mu by E, sigma x plus sigma z, and Ez is equal to the sigma z by E minus mu upon E, sigma x plus sigma y. These six equations are known as generalized Hooke's law equations. Okay, three linear strains and three shear strains. Okay. Okay. Now come to the last topic of today's lecture, relation between elastic constants. Consider a cube ABCD subjected to a force, a shear force F A B C T. Okay. Consider a solid cube ABCD which is subjected to a shear force F. Let tau be the shear stress developed in face BC and AD due to the shear force F. So the direction of the shear stress will be like this. So the direction of shear stress along the plane AD will be is like this. The complementary shear stress produced in the face AB and CD due to the shear stress which is produced by the force F is opposite to the direction of this shear stress. This complementary shear stress is opposite in the direction of the actual shear stress. Okay. Due to the shearing force, cube is distorted to A B dash C D C dash D. B point is displaced to the B dash point, and C dash point is displaced. C point is displaced at C dash point. Here, this angle is phi, which is also known as shear strain. Okay. Okay. Here, shear strain phi will be equal to the CC dash upon CD. We know that the shear strain is equal to the Cc dash upon Cd. Okay, and we also know that shear strain phi is equal to the shear stress upon modulus of rigidity. Okay, now from these two equations, Cc dash upon Cd is equal to the tau upon G. Equation number 1. Okay, now draw a perpendicular on the diagonal AC dash from the point C, CE. Okay, here strain in the diagonal will be equal to the A EC dash change in dimension upon initial dimension. The initial dimension is AE. AE and AC are equal. Okay, so initial dimension is AE and change in dimension is EC dash. So from here, diagonal strain will be equal to the change in the dimension, which is EC dash, and initial dimension. Here AE is equal to the AC. Okay, okay, let's say this is equation number 2. Now here the change in dimension is very small, so this angle and this angle are equal. So in a cube or in a square, the angle, this angle will be equal to the 45 degree. So this angle is also be equal to the 45 degree. So now from this right angle triangle CC dash E, CC dash E, EC dash will be equal to the CC, EC dash will be equal to the CC dash into cos 45. Okay, from right angle triangle CC dash E, EC dash is equal to the CC dash cos 45, or say CC dash upon under root 2. Okay, and from right angle triangle ACD, ACD, AC is equal to CD. Basically this angle is 45 degree, so then cos 45 is equal to CD upon AC. Okay, so from right angle triangle ACD, AC will be equal to the CD into under root 2. Okay, putting these value in equation number 2, we get diagonal strain will be equal to the CC dash upon CD under root 2 into under root 2, or say cc dash upon 2 into cd. Okay, but cc dash upon cd is equal to tau by g. This is shear strain. So the diagonal strain will be equal to the tau upon 2g. Okay, let's say this is equation number 3. Here, if here the normal stress due to the shear strain sigma n a due to the shear strain stress tau a sigma n, in that case the diagonal strain will be equal to the sigma n upon 2g, and the strain in total strain in along the diagonal, the diagonal strain will be equal to the sigma n upon e 1 plus mu using generalized Hooke's law. Here the stress in the diagonal BD is compressive and the stress in the diagonal AC will be tensile. The diagonal BD is perpendicular to the diagonal AC, so from the generalized Hooke's law, strain in the direction of AC will be equal to the sigma n upon E, which is lateral strain, minus mu by E into sigma n, which is minus. So the minus minus will be the plus. So here this will be also equal to the diagonal strain. So from these equations, sigma n upon 2g is equal to the sigma n upon E 1 plus mu, or say E is equal to the 2g 1 plus mu. Okay, now let the on this solid cube, each face having a normal stress sigma n. In that case, strain in a particular direction will be sigma n upon E minus mu by E into 2 sigma n. Strain in a particular direction. When normal stresses, normal compressive stresses are acting in each phase, sigma n. Okay. So from here, sigma n upon E is equal to 1 into 1 minus 2 mu. This is the linear strain in a single direction. Now the volumetric strain, because the stresses are acting in each phase from each direction, then the volumetric strain will be equal to the 3 times of linear strain, which is sigma n upon E 1 minus 2 mu. We also know that volumetric strain will be is equal to the volumetric stress upon bulk modulus. So from here 3 sigma n upon E 1 minus 2 mu, sigma n to sigma n is cancelled. Here E is equal to the 3k 1 minus 2 mu, where k is the bulk modulus. Okay. Now end this class at this topic. Okay. नेक्स्ट लेक्चर में इसके आगे हम लोग डिस्कस करेंगे. थैंक यू वेरी मच.